Okay, so in question 2 of the final exam review material, we're looking at a kinematics graph question where we're given an acceleration time curve. So an object moves according to this acceleration time graph, and at t equals 0 we're told the object has a positive velocity. Then we have to make the connection between this acceleration time graph and a position time graph that's consistent with this acceleration time graph. So there's a couple of things you could start with this question. There's a couple of options. You could just focus in on the sentence that at time t equals 0 the object has a positive velocity to rule out some choices. So in order for the object to have a positive velocity at t equals 0, the slope of the position time curve at t equals 0 must be positive. So that's at least consistent with graphs A. We have a positive slope here at the beginning. Graph B has a positive slope at the beginning, and graph C has a positive slope at the beginning. But graph D has a negative slope, so graph D is not consistent with the description that the object has a positive velocity time equal to t equals 0. But graph D is in here for a reason, for a different reason, which I'll explain in a second. So we can rule out choice D, but to show you why D is in here as a choice, let's try and draw a velocity time curve that's consistent with this AT curve. So maybe I'll just only draw it right below it. This is our Vt. So we're told is that the velocity has a positive velocity at the beginning. We don't know how positive it is, but I do know it is positive. And then there's a there's a negative acceleration for a long time period, and then a positive positive acceleration for a smaller time period. And it looks like the magnitude of that positive acceleration is less than the magnitude of this negative. So there's going to be a large negative delta V, the area underneath this particular piece, compared to this area under here, this positive delta V. So a consistent Vt graph, so we start with a negative, and maybe if I just show this is drawn very roughly here. This is going to be, so I would draw a negative sloping V. It could go, depending on how large the initial velocity is, it could go start positive and end up negative, which I do here. And then we'll have a shallower slope until the shallower slope for the second acceleration. That's a positive slope. So this would be a consistent Vt graph, which is why D is a distractor. So D is actually the shape of the velocity time curve and not the position time curve. But what we will know for sure is that this shape can move up and down. In a sense, it could move up as long as the initial velocity is positive, so it could be anywhere as long as the V is positive all the way upwards, so it doesn't necessarily have to go below the time axis and become negative. But what we do know is that if the object has initially a positive velocity and a negative acceleration, it will mean that the object slows down, that the velocity will become less positive over time. So if we take that particular information, we know that we originally knew that D wasn't correct. We can look at graph B. Graph B shows two constant velocities. So a constant positive velocity and a constant negative velocity. But since the object is accelerating, and this is not a possible correct graph because the velocity has to change. So the position time curves must be parabolic in shape, or a mix of some parabolas. So B cannot be true. So we're down to choices A and C. Now what you'll notice here for graph A is if I draw some tangents at the beginning, we would have initially a positive velocity, but if you notice is that the velocity gets more positive over time before it slows down. So for this particular object A, the actual object is starting with a positive velocity in a negative position, but that doesn't matter. So it starts with a positive velocity that's getting more positive. So that would be consistent with an object having a positive velocity and a positive acceleration, which is not what is consistent with this graph. So A cannot be correct, which does leave you with the correct choice, of course. But here, just to finish out the explanation, we start with a positive velocity, sort of steep positive slope, that eventually gets less positive, and then almost pretty much comes to rest and then speeds up again, which wouldn't be consistent with this exact VT curve. But were I to draw a VT curve where so velocity time curve, again, it would have the same shape, but it would just start with a higher initial positive velocity. Then roughly at this time here, the velocity is almost zero, and then becomes, so that these two graphs will be consistent. But again, this VT curve, same shape, is consistent with this AT curve. I just changed the initial velocity, but then graph C is still correct in that we start with a positive velocity that gets less positive over time, and that's consistent with an initial positive velocity and an initial negative acceleration. So makes graph C the correct choice.